All right, so today we're going to be doing mostly review of what we've done this week. We're going to talk about one new thing I don't think we mentioned. So we've talked about what happens when you have something to a fraction power when the top number is 1, the numerator. For instance, we said, let's just look at a couple of these. So we said if you have something to the 1/2 power, that means you're taking a square root. If you have something to the 1/3 power, that means you're taking a cube root, a third root. If you have something to the 1/4 power, that means you're taking a fourth root. And so on. 5th power would be 5th root. And remember what these mean. This means what number multiplied twice is 25, that'd be 5. This means what number multiplied 3 times is 8, that'd be 2. It's 2 times 2 times 2 is 8. This means what number multiplied 4 times is 16, that'd also be 2, because 2 times 2, 4 times is 16. So the question is now, what happens when the numerator is not a 1? So let's say we have 25 to the 3/2. And see, I'm trying to remember if we have done this. I think I put it in a video, but I don't remember if it was the video that we ended up using. So anyways, it might be review. We may have said this already, we may have not. We'll just go over it kind of from scratch either way. There's not too much to it. So basically the bottom number, as we've seen, this tells you what root you're taking. And the top number, we can think of as the exponent. This isn't really technically correct to think of it this way because they're both really part of the exponent, but I think this kind of makes it a simple way to think about it. So this is saying that we're taking the second root and we're raising it to the 3rd power. So that means we're taking the second root and raising it to the 3rd power. So you just have 2 things you're doing. That's all it is. So square root of 25 would be 5. And 5 cubed is saying multiply 5 3 times. That's 5 times 5 times 5, which would be, let's see, 5 times 5 is 25, times another 5 is 125. So our answer here is 125. Let's say we have 27 to the 5/3 power. This may end up being a big number, we'll see. Actually, yeah, it kind of is. But let's go ahead and do the same thing. So we see, again, the bottom number is the root we're taking, the top number is the exponent. So we're taking the cube root, the 3rd root of 27, and then we're raising that to the 5th power. So just break it apart. So cube root of 27, what number multiplied 3 times gives you 27? That'd be 3. 3 times 3 is 9, times another 3 is 27. So this is 3 raised to the 5th power, which means multiply 3 5 times. Now let's see what we get. 3 times 3 is 9, times another 3 would be 27, times another 3. Let's see, 3 times 20 is 60, 3 times 7 is 21. 60 and 21 gives us 81. And then 81 times 3 is going to be 243. But at that point, you could put it into a calculator. So at this point, the idea is that we wouldn't be plugging this into a calculator. You could plug it into a calculator and give you the answer, but we want to show all these steps here. So the calculator is not really going to help us with those. But at this point, when you're just multiplying out the number, that's fine. Go ahead and use a calculator if you like. So 243 is our answer here. Also, as a side note, so like that first one we did 25 to the 3/2, we said that's square root of 25 and then raised to the third power. You could do either one first. You can square root it first and then cube it, or cube it first and then square root it. So you also could write it like this. Oops. So in this one, you're square rooting first and then cubing. In this one, you're cubing first and then square rooting. Probably a good deal of the time, it's going to make more sense to do the root first and then the exponent. So this way. But you can try it out both ways and see which way is either going to work or is easier to do. But probably both ways should work. But there may be some cases where you would need to do one instead of the other. Can't think of anything off the top of my head, though. So let's try one practice before we move on. Let's say we have let's try 30, let's say 16 to the 3/2. So let's go ahead and pause the video and give this a try. All right, so 16 to the 3/2. We're taking the second root, the square root, and we're raising it to the third power. So we have square root of 16 raised to the third power. Square root of 16, again, that's what number multiplied 2 times is 16. That'd be 4, because 4 times 4 is 16. And then here, 4 raised to the third power, that's saying take the number 4, multiply it 3 times. 4 times 4 is 16, times another 4 would be 64. So 16 to the 3/2 power is 64. So that's that. Now let's go ahead and move on to review. So first, we just have basic exponents, and we've kind of been talking about this already as we've been doing these other problems. But let's just go ahead and review. So the exponent is just saying how many times you're multiplying the base. So this is saying we're multiplying a base of 9 2 times. So 9 times 9. That'd be 81. Also, another important rule, remember anything raised to the 0 power is always 1. That's a bit of a weird rule. And then lastly, anything raised to the first power is always itself. Anything to the 0 power is always 1. Anything to the first power is itself. So let's go ahead and talk about some of our basic properties. We had the power, what we can call the product property. That's talking about multiplication. The quotient property, that means division. And the power property, which is when we have a power raised to a power. So this one was like, so these 3 properties would help us simplify in these cases. So the product property tells us what we can do when we have the same base and we're multiplying. So base is 5 in both of them. So we have the same base, we're multiplying. So if you remember, that tells us we can add our exponents. So that'd be 5 to the 9th. Quotient property is basically the same thing, but with division. It says if we have the same base and we're dividing, you can subtract the exponents. So 4 to the 7 minus 3, it's always the top one minus the bottom one. And that's going to give us 4 to the 4th power. So you could keep going from here. Obviously, you could say this would be 4 multiplied 4 times and figure out what that equals. But here and on the classwork, we'll just say use these properties to combine the exponents, at least at first, and then we'll do more complicated ones where we want to simplify all the way. So this last one, if you remember, when we have a power raised to a power, that's telling us to multiply the exponents. So it'll be 3 to the 10th. So let's go ahead and try some practice for these. All right, so let's pause the video and try these. We have 2 to the 7th times 2 to the 3rd, 5 to the 3rd over 5, and 7 to the 3rd raised to the 2nd power. So again, let's pause the video. Let's give these a try. All right, so first one, we see we have the same base and we're multiplying. They're both 2s. So this can become 2 to the 7th plus 3, which is 2 to the 10th. And again, keep in mind, they have to be the same base. If the original problem was 2 to the 7 times 3 to the 3rd, we couldn't have used this property because they're different bases. But here we have the same base. Now, a second one, letter B. For this one, you want to remember that if there's no exponent, it's technically a 1. So here we can do 5 to the 3rd minus 1, which is 5 squared. And the last one, power property, we have a power raised to a power, so multiply them. And we get 7 to the 6th power. So next we'll talk about negative exponents. Negative exponents are maybe a little tricky. Let's look at some different scenarios. Let's make some more room. So what do we do in each of these cases? So our goal here is to make the negative exponent positive. And when we're dealing with the signs of exponents, we want to think about things in terms of fractions. So if you notice, the last 3 here are all fractions already, but the first one's not. So if we have a negative exponent and it's not part of a fraction already, let's just put the whole thing over 1. You can always do that and you're not changing it technically. So when we have an exponent and we want to change the sign of it, all we have to do is move that whole thing over the fraction line. When something moves over the fraction line, either from the top to the bottom or from the bottom to the top, it changes the sign of the exponent, which means if it's negative, it's going to become positive. So this 5 to the negative 3rd, it's now going to be on the bottom. It's going to be a positive 3. Technically, the 1's still down here, but it's just a times 1, and 1 times anything is itself. So we don't really need to rewrite that 1. But there's nothing left up top. If there's nothing left, you put a 1. And that one does need to be there. Otherwise, it would just look like this, but we need something up there. So there we go. And again, you could keep simplifying from there, do 5 times 5 times 5. But for now, we'll just leave it like this. So this next one, it's already a negative exponent. I mean, it's already a fraction. So we need to just move it to make it positive. This one's on the bottom, which means it needs to go up top. And so on top, we're going to have 3 to the positive 3. There's nothing left on bottom, so we need to put a 1. And in this case, anything over 1 is itself, like we set up here. So this can actually just go away. We don't need it. So we just have 3 to the third. Careful, you can't do that when the 1's on top. Only when it's on bottom. Now this next one, we have multiple negative exponents. So that means both of them need to move. So this one will need to move up to become positive. This one's going to need to move down to become positive. So basically the whole thing's just flipping. We're going to have 3 to the positive 7th over 2 to the positive 5th. And then in a case like this, there's only one negative. The other one's positive. So 3 squared, that can stay where it is. If we move it, then it's going to become a negative. This one, though, is a negative, so we need to move it to make it a positive. So we have 3 squared up top, and now we have 5 to the third up top. Nothing's left on bottom, so we put a 1. And these are being multiplied, so we'll just put them in parentheses like this to keep things neat and show they're being multiplied. And in this case, we have that 1 on bottom, which doesn't need to be there. So we can just make it 3 squared times 5 cubed. So we're going over this stuff a little bit quickly just because there are things we did before, but feel free to rewind the video if you need to see them again. So let's go on to the next practice. Okay. So for these, just make the negative exponents positive. All right, so go ahead and pause the video and give these a try. All right, so let's have a look. The first one, we have a negative exponent, but it's not in a fraction. So if you remember, we need to put it over 1. And if it has a negative exponent, it needs to cross over the fraction line to change the sign of the exponent. So this is now going to go onto the bottom, 7 cubed on bottom. We don't need to write this 1 down there with it because it's just 7 to the third times 1. And anything times 1 is just itself. So it doesn't need to be there. But there's nothing left once we move this up top. So we need to put a 1 in there. So 1 over 7 cubed. Letter B, it's already a fraction. So we just need to go ahead and take this and move it. So we're going to have 5 to the positive 3 up top. There's nothing left on bottom, so we put a 1. And again, when the 1 is on bottom, it doesn't need to be there because 5 to the third over 1 is just 5 to the third. And last one, we have 2 to the 5th. That's already a positive exponent, so it stays on bottom. And this one needs to move to become positive. So it's going to be 7 to the 8th on the bottom. Put them in parentheses to keep things neat and show that you're multiplying them. There's nothing left up top, so we put a 1. And there's our answer for this one. Next, we have simplifying radicals. So let's say we have square root of 27, square root of 50. So if you remember, we did these when the numbers inside the radical turned out to not be perfect squares. And this is where we were thinking of that big list of perfect squares. It's like 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225. So ideally, the number inside the square root would be one of these numbers. That makes it easy. But in this case, neither of them are in this list. So then if you remember, we're looking for numbers that can multiply into the numbers we have here. So which one of these can multiply into 27? That's going to be 9. 27 is 9 times 3. We can split those apart to become square root of 9 times square root of 3. Square root of 9 is 3. And if you remember, we can just squish them together. We don't need this multiplication symbol. It's implied. And we get 3 rad 3. Then let's look at square root of 50. Which one of these numbers can go into 50? That's going to be 25. So we can rewrite this as 25 times 2. Break it apart. Square root of 25 is 5. 5 times rad 2 is 5 rad 2. All right, let's go ahead and try a quick practice with this. Let's say we have square root of 12. So let's pause the video and give this a try. All right, let's have a look. So 12 is not one of our numbers, our perfect squares. So we're looking for which of these can go into it, besides 1, because 1 can obviously go into anything. So this one, 4 can go into it. So we'll rewrite it as square root of 4 times 3. Break it apart. 4 times square root 3. And then square root of 4 is 2. So we have 2 rad 3. Okay, just a couple more things to go. This next concept we won't do practice for. We'll just do a refresher. So this is when we have quantities raised to an exponent. That word quantities usually or can often refer to when you have parentheses. So we have quantities raised to exponents. And so when you have multiplication on the inside, remember that the exponent goes to all the different things being multiplied, all the factors. When you have division, it goes to all the different things being divided or that are part of the division. So here we have 2 cubed times a squared cubed times b to the third cubed. So we're just taking this 3 and applying it on to all the factors. And so 2 cubed, that's 2 times 2 times 2. That's 8. Here we have a power raised to a power. So remember to multiply. 2 times 3 gives us 6. Power raised to a power. 3 times 3 gives us 9. So there's our simplified expression there. Next, over here, we have 3 squared over 4 squared. 3 squared is 9. 4 squared is 16. So 9 over 16. Okay. Oh, and we already reviewed the next thing we were going to mention. So now we're basically at the end, and we're just going to be applying all these different things in order to simplify more complex types of expressions. So let's take a couple. Let's say, for example, we have, let's take one that just combines a couple things together. Let's say we have 2 to the 4th raised to the 5th power over 2 to the 18th times, I don't know, let's make this 22 and 2 to the 1st. So let's say that we're being told, the instructions here are to simplify this completely so that there are no exponents left without using a calculator. So what are we even going to do? And let's just make it the same color. So one thing that stands out is that they're all 2's here. All of our bases are 2. So we're probably going to be able to use some of those properties, the power property, quotient property, product property maybe. So let's see things we can start doing. So here, first thing that stands out is that we have a power raised to a power. So let's go ahead and multiply those. So we have 4 times 5 gives us 20. So we have 2 to the 20th over 2 to the 22nd times 2 to the 1st. Now we have division and we have the same base, so we can subtract the exponents, always the top one minus the bottom one. So 20 minus 22. 20 minus 22 is going to give us -2. So we have 2 to the -2 times 2 to the 1st. Then here we have multiplication and we have the same base, so we can add our exponents. So we have 2 to the -2 plus 1, which would be 2 to the -1. Now we have a negative exponent. We want to get rid of the negative exponent. So remember, if it's not a fraction, put it over 1. And to change the sign of this exponent, we're going to need to move this over the fraction bar to become positive. So now we're going to have 2 to the +1 on bottom. There's nothing left up top, so we put a 1. And 2 to the 1st power, if we remember, that's just 2. So we just get 1 over 2, which is 1/2. So we'll pause here for a moment if anyone's getting this down, because we'll go ahead into a practice problem similar to this one. All right, let's have a look, or let's come up with a practice. And I lost count of which one we're on. I think maybe this is number 5. But if I'm wrong, just put whatever number it is. So let's say we have 3 to the 3rd times, let's say 3 to the 12th over 3 to the, let's see, 6. Let's say we have this 3 to the 3rd times 3 to the 12th over 3 to the 3rd raised to the 6th power. So let's go ahead and pause the video and give this a try. All right, let's have a look. And now things are getting pretty difficult, so don't be surprised if you're finding it difficult. We're trying to put together a lot of pieces now for basically the end of this exponent unit. So it looks like all of our bases are the same. It looks like we have 3's for all of them. So again, just like the last one, we're thinking about those 3 properties: product property, power property, quotient property. And here we notice we have a power raised to a power. We have this division here, this quotient, but before we do that quotient property and subtract the exponents, we need to simplify that power raised to a power. So let's start there. So we still have 3 to the 3rd. We're not going to touch that one yet. And we have 3 to the 12th up top. And on bottom, multiply the 2 exponents, the 3 times the 6, that gives us 18. And then we have the same base and we're dividing, so subtract top one minus the bottom one. 12 minus 18, that's going to give us -6. Then we're multiplying and we have the same base, so we can add the exponents. We have 3 plus -6. Plus negative is just the same thing as minus. So this is really 3 minus 6, which is -3. And we have a negative exponent. We want to make it positive. It's not in the fraction, so put it over 1. And this needs to move to become positive. So we're going to have 3 to the positive 3 on bottom. There's nothing left up top, so put a 1. And 3 to the 3rd, we can simplify. That's 3 times 3 times 3, which would be 27. So 1 over 27. A lot of steps to get to that point. And make sure on classwork you put all these steps, or at least as many as you can get. And so let's maybe go over one last thing, one last type of problem. If you remember when we had something like this here, let's say we have or like and so we'll look at these. We won't do practice problems. But let's have a look. So this one, if you remember, the thing we want to stand out here is when they have the same exponent. So here they're both 1/3. Here this is 1/2. And also remember, square root is also a 1/2 exponent. So we can rewrite this as 2 to the 1/2. Remember, when they have the same exponent, we can pull it to the outside. So we have 2 to the 8, or 2 times 8 on the inside, 1/2 on the outside. We can do the multiplication on the inside now. That's going to be 16. Now that we were able to change something, we changed 2 and 8 into 16. Now let's try turning this back into a square root symbol. And that works out because 16 is a perfect square. Square root of 16 is 4. Then let's look over here. We have 16 to the 1/3, 2 to the 1/3. Same thing, they have the same exponent, so we can pull it out. So then we're going to have 16 over 2 raised to the 1/3 power. We can divide on the inside. 16 divided by 2 is 8. Let's turn that 1/3 power into a cube root. And cube root of 8 is 2, because 2 times 2 times 2, that's 3 2's, equals 8. So first one we got 4, second one we got 2. And then just a quick mention before we end the video. Sometimes, let's say you have something like let's just say we have 25 to the 6 over 4. We talked about exponents, fraction exponents earlier, but this is just a comment. You can simplify the exponent if it's able to be reduced. So like 6 over 4, instead of having to raise it to the 6th power and take the 4th root, we can simplify 6 over 4 to 3/2. Then we only need to take the square root and cube it. So much more manageable than trying to do 6 and 4. So if the fraction can simplify it. With that, we'll go ahead and end this video and work on classwork number 5, which is just kind of almost, it's basically like a review package.